Welcome to HideScience.org. Today we're going to be discussing the heating curve. Hopefully by the end of this session you will understand what kinetic energy is, the ordered particle arrangement, degree of freedom, intermolecular forces, energy level transitions, and how to find the melting, freezing, boiling, and condensating points. This is our heating curve. Let's first notice that our temperature is on our y-axis and energy goes across the x-axis. Kinetic energy is our first topic. Kinetic energy is measured by temperature. So the first thing we need to do is to see, is the temperature changing as we read the graph. So we're going to start here at this point on the graph. And as we go, if our ruler goes up and down, then our temperature is changing. If our temperature is changing, our kinetic energy is changing. So as we start, our ruler starts to rise, so our temperature is changing. As we continue here, notice our temperature does not change. Our ruler does not move up or down. So our temperature is not changing, so that means our kinetic energy is remaining constant. As we continue, temperature increase, means kinetic energy increase. No temperature change here. And then here we have temperature change again. Alright. So if our temperature is changing, then our kinetic energy of our particles, or the motion of the particles, is changing. If our temperature is rising, then our particle motion is becoming faster. If our temperature is falling, then our particle motion is slowing down. Let's take a second to look at the arrangement of the particles at our solid stage, our liquid stage, and our gas stage. As you can see, our solid phase particles are in a more orderly or ordered structure. And as we move to gas phase, our particles become less orderly and more chaotic in nature. We can also describe these as a degree of freedom. In the solids, they have very little degree of freedom. They're stuck where they're at. They do not move much. They just vibrate in place. And as we move to the gas phase again, the gas particles will have more freedom, or a higher degree of freedom, than any other phase. Next on our list is intermolecular forces. Again, we'll look at it through the phases. As we move from down here in our solid phase, have a very strong intermolecular forces. They're held together very tightly compared to the gases, which don't really have any intermolecular forces to speak of. So as we move up our graph, we've got to loosen those intermolecular forces so the particles can spread out. So here, when we go through the phase change, we're loosening intermolecular forces, and we're going weaker and weaker and weaker intermolecular forces as we increase our kinetic energy. Energy level transitions. This is important and goes along with identifying melting and freezing points. So here we have our phase changes happening at our horizontal lines. And it's easy to pick out the melting points if you think about energy transitions. So at this phase change, if I'm going this way, all right, a solid is a lower energy state versus a liquid, which is a higher energy state. So if you're going from a solid to a liquid, you're going from a low energy state to a higher energy state, you must be talking about melting. If you were to go in reverse, if you was to go from a liquid to a solid, you'd be going from a higher energy state to a lower energy state. So there you know we're talking about freezing. If you're trying to find your melting point, we know we're melting going this way. So right here, where we start to melt, is going to be our melting point. So we go to this point here, and we know that our melting point is going to be 0 degrees Celsius. We're looking for our freezing point. Coming back down this way, cooling off, we start to freeze here as we phase change. So we see that our freezing point is also 0 degrees Celsius. And finally, the same thing with our gas phase here. As we go from a liquid to a gas, lower energy to higher energy, okay, that would be boiling, or higher energy to lower energy, that would be condensating. We can find our melting point or our boiling point by following this line over to our temperature, and see that our boiling point and our condensating point is at 100 degrees Celsius. Thank you for tuning in for this version of the Heating Curve vlog. Hopefully all of these make sense to you now. Please comment below or comment on the help section if you would like to see any other posts or vlogs about any comments. Thank you.